In today's lesson, we are going to be looking at graphing the standard form. So we've looked at graphing vertex form, we've looked at graphing factored form in our previous units, but today we're going to look at graphing standard form, and it's going to combine what we've looked at in the first part of this unit. So recall, what information do we need to graph a quadratic relation? What are some things that we need to have to be able to graph a parabola? So you can think back to the previous unit where we were graphing or determining equations from vertex form and factored form, right? We need to know the zeros. So we need to know our zeros, right? Or our x-intercepts. That could be one thing. Because if I know my x-intercepts, I kind of know where it crosses the x-axis. It gives me some idea of where the points are. With the zeros or the x-intercepts, we could also find the axis of symmetry, right? That middle value. If we're wanting to graph, we do need to know the vertex. We need to know where the highest or the lowest point of our parabola is. We need to know where that is, because again, that gives us an idea if it's opening up or opening down. Just if we know the zeros and the and the vertex. We do need to know the axis of symmetry. We need to know the axis of symmetry because again, that will help us figure out the other values, right? It's that middle line. It's that line that kind of divides our parabola in half. So if we know the axis of symmetry, then it's easy to figure out, well, not easy, but we can use that as like kind of a stepping stone to find some other information. And we know where the middle of our graph is. We might need to know, or we probably need to know the direction of the opening. Right? We need to know which way our parabola is opening. Is it opening up or opening down? That will help us when we graph it, or at least help us know if we're on the right track. And I would say, again, our maximum minimum value, right? Our optimal value, again, that comes from our vertex, right? Remember, our vertex is basically two values. One would be the axis of symmetry, our x value, and the other one would be our max or min, right? The y value, right? So our vertex actually does give us two of these other pieces of information. But again, not that we need all of these to graph it, but I would say we need a good portion of them, right? We need the vertex and the direction of the opening, or we need the zeros in the direction of the opening. But given these different pieces of information, we can find or use it to find some of the other ones. So what we're going to deal with, though, in this case is the standard form, right? And what key information are we able to get from the standard form? Right? And if we want the general form for the standard form, it's y equals ax squared plus bx plus c. Right? So what information does this standard form give us about our quadratic? So we have the equation y equals 3x squared plus 4x minus 6. It's graphed for us here. What information can we see from the equation that appears on the graph? Right? Where do we see 3, 4, or negative 6? Well, we don't see 3 or 4 anywhere, like in our parabola here. We don't see that come up in any of the points. It's not our vertex, right? Our vertex is down here. It's an unknown. It's not a nice value, right? It's not any of the x-intercepts, right? Those are up here. Right? So again, those aren't, we don't see those values anywhere. However, what we do see is that our y-intercept is here. And our y-intercept does happen to be negative 6, which is this last value. So that last value in our standard form gives us our y-intercept. Right? And think about what other information do we have from this parabola. Right? You could argue, again, the axis of symmetry, which looks like it's somewhere below negative 1, maybe like negative 0.5. Again, or 0.75. Again, we don't see that come up in our equation. Maybe you could say, well, 3 divided by 4. But again, I'm making a guess or an estimation that axis of symmetry is at negative 0.75. The only other thing for sure that we can get from our equation and that we see in our parabola is this a value, right? And this a value tells us the direction of the opening. So in this case, it's telling us, right, because it's a positive, that this parabola opens up. Now again, based off of the y-intercept and the direction of the opening, there's not enough there to help us graph, right? If I just knew this red dot and then that it was opening up, that's not enough really to help me. So we do need to do something to this standard form equation because there's just not enough here at this time. And again, that's where what we learned in the first half of this, or the first part of this unit, comes into play. Right? So for graphing standard form, what we want to do first is we want to factor the quadratic relation. We want to factor the quadratic relation because once I factor it, it becomes factored form and I can find the zeros or the x-intercepts. Right? So our goal is to factor so we can find our x-intercepts. Once we find the x-intercepts, we can find the axis of symmetry because it has to be in the middle. Right? The axis of symmetry is halfway, or it's the middle. It divides our parabola into two. And if I know my two x-intercepts, the axis of symmetry is going to be in the middle of that. Once we find the axis of symmetry, we can plug that in to our equation because it is an x value. We can plug that into our equation and use it to solve for y. And the reason we can solve for y, or the reason we're going to solve for y, is because that x value, since it's the axis of symmetry, is going to be the x value of our vertex. Once we have our vertex, we'll have our zeros, we'll have our axis of symmetry, we'll have the direction of the opening, and then we can graph all those points and graph our parabola. So let's go through those steps with this quadratic in standard form. So I want to graph 2x squared minus 18x plus 16. Right, if I graph this, right, or first step should be to factor. So if I look at this, right, it is a complex trinomial. There is a perfect square at the end of 6, but 2 is not, or 16, sorry, but 2 is not a perfect square. So it's not a perfect square trinomial. So let's try to factor. The first thing we should do is common factor, right? Or check to see if we can common factor. In this case, 2 is a common factor because I can take a factor of 2 out of every term. I'm then left with x squared minus 18x, or not 18 anymore. Actually, let me just write down the first step. We're going to factor. I'm going to take a common factor of 2 out. I'm left with x squared minus 9x plus 8. So now I'm going to factor the trinomial in the bracket, product and sum. Two numbers that multiply to 8, add to negative 9. We have negative 8 and negative 1. I don't need to factor the long way because it is a simple trinomial. So I'm going to have two brackets, x minus 8, x minus 1. Now I've factored. Now that I've factored, we need to find our zeros. Our zeros, our x-intercepts, whatever you want to call it. Now it is an easy one because it's a simple trinomial. There's nothing fancy about our brackets, but I'm going to show you the longer way, or the algebraic way of determining the x-intercepts, just so that if we get something different, we can still apply the same steps. So what we're going to do is we're going to set each bracket equal to 0. Similar to what we've done before, x minus 8 equals 0, 2x minus 1 equals 0. I'm going to solve for x, move the 8 over, it becomes positive 8. Move the 1 over, it becomes positive 1. These are my two x-intercepts. The next step is going to be to find the axis of symmetry, that AOS. Now the axis of symmetry is halfway between my x-intercepts. It's in the middle. So I'm going to say x equals
8 plus 1 divided by 2. We add up our two x-intercepts and divide by 2. We find the halfway point. So we get 9 divided by 2. Which gives us 4.5. The last step, we're going to plug the AOS in and solve for y. So this axis of symmetry, this 4.5, that is the x value of our vertex. So we're going to plug that into our equation. 2x squared minus 18x plus 16. We could plug it back into this one. We could plug it into our factored form, whichever one we want. 2 times 4.5 squared minus 18 times 4.5 plus 16. This just becomes a long calculation. We should get negative 24.5. So now our vertex is the axis of symmetry and this y value. So 4.5 and negative 24.5. I have my zeros or my x-intercepts. Now I have enough information to plot my graph. Right, so I can plot a point at 1. I can plot a point at 8. My axis of symmetry. I don't need to plot it, right? Because I'm just using that to help me find my vertex. My vertex is at 4.5 and negative 24.5. So all the way down here. I don't need to know what direction of the opening is, right? Because based off of this graph, it has to open up. But if I wanted to, I could look back at my A value and it does tell me that it opens up. I do also know, we can go back up here. We could say opens up because my A value here, my C value at the end tells us the y-intercept is 16. I'm going to have a point, positive 16. Positive 16, I don't really have that on here, but at least I know it's going kind of upwards like this. Not the nicest curve. But again, something along those lines, right? Because again, it's not going to be 100% accurate, but at least it should be a rough sketch. It gives us an idea of what it looks like. We're going to try the same thing with just one more example. So we have a standard form equation, right? Right off the bat, we just want to look for, okay, we didn't really do it first on the last one, but we can do it first here, right? We can say it opens up because of our A value, and our last value here tells us that we have a y-intercept of negative 20. So with those same steps, first step is going to be to factor. So it's a simple trinomial, so x squared minus x minus 20. So I'm looking for two numbers that multiply to negative 20, but they add to negative 1. These two numbers are negative 5 and positive 4. So now I can factor this x minus 5, x plus 4. Because of this form, I could just, y equals, I could just go through and just say, okay, for when I find my x-intercepts or my zeros, I could just say, okay, my zeros are positive 5 and negative 4. Again, I'm going to show the steps, set each bracket equal to 0, just so that if we get something different, we know what to do. X equals positive 5, x equals negative 4. Again, if you can quickly just jump to that because you know those are the x-intercepts, that's fine. Like I said, you may come across situations like we have in the past in previous lessons, in the previous unit, where you might have to find, you might have to actually do this method because it's not as easy depending on how we factored. So we found our zeros, so now we can find our axis of symmetry. So it's going to be x is equal to
5 plus negative 4. We add our two values and divide by 2. So 5 plus negative 4 is negative a half, or sorry, not negative half, positive a half, or 0.5. The last step, we're going to sub the AOS and solve for y. So we're going to plug that value in. I'm just going to go back to the original equation. You can use the factored one. It doesn't really matter as long as you can calculate it properly. So 0.5 squared minus 0.5 minus 20. We should get minus 20.25. So now with that value, our vertex is the point 0.5 and negative 20.25. That's enough information to go through. And now I can graph my quadratic. So similar to graphing factored form before, which we've done in a previous lesson, but we just had a different starting point. So I'm going to plot my two x-intercepts. We have positive 5 and negative 4. Negative 20 is a y-intercept. I can graph that one. And then negative 0.5. Or sorry, positive 0.5 and negative 20.25. So just kind of below there. I'm going to join my points. Not the greatest. Again, it's more of a rough sketch based off of the values that we have. But now we have our graphed quadratic. So again, it's kind of combining, or it's a continuation on what we've looked at in previous lessons. In previous lessons, we've looked at graphing a factored form equation, right? We did that in the previous unit. Here, the only difference is we're starting with an equation in standard form, and we're factoring it to get to that factored form. So a lot of these steps hopefully are familiar, right? Because we've just done them in a previous unit. Now we're just adding in a little bit of an extra step of factoring at the beginning, and the factoring we've looked at the beginning of this unit.